Welcome everyone to Good Talks and the latest episode of our live stream series. I'm Harry Dix, Senior Content Manager here at Good Data. If you're new to the show, the basic idea is that once a month, I convince my colleagues, connections to join me and share their expert views on different kind of topics, their opinions, their advice surrounding kind of data and analytics and BI related topics. Today's show is centered around data storage, often overlooked yet super important aspect of data analytics and BI. To discuss that with me today, I'm joined by Maria Leal. Welcome to the show, Maria. Thanks for joining.
Thank you.
Maria is senior sales engineer here at Good Data. She's got a background in kind of data integration and building data pipelines before joining our sales engineering team here at Good Data. As mentioned, we'll be covering the topic of data storage, namely why it's important, yet often overlooked, what kind of data storage types there are, why you would choose different ones in different scenarios, different use cases, as well as some of the current kind of trends around data storage within the analytics and BI space. Hopefully all the insights you need to make kind of informed decisions regarding the storage of your data. We'll answer these questions and more, but as always, please ask any questions, pop them into the comment section. We'll either address them as we go along, or if we have time at the end, we'll try to address them there also. If we don't get around to answering all of them, rest assured we'll get back to you within the comment section after the show. So let's jump in. I mean, in a nutshell, what is data storage and why is it kind of so important for data analytics? Why are we here speaking about it today, Maria?
So in very simple words, data storage is a way to retain data and to make it accessible when needed. And the reason why it's so important is because the way that this data is stored directly impacts your analytics. So when you're properly storing it, you're able to integrate data coming from different sources, have access to historical snapshots of your data, which can then be used to perform analysis on trends and patterns.
And I guess, I mean, of course, the idea is to store it in the best way possible. But to understand that, how would you kind of define badly stored data? What happens if I have data and I store it kind of improperly? What's the consequences?
So there are quite a lot of consequences because it really depends on in what way you have it poorly stored. So let's say if you don't have proper backups of your data, so you're risking losing important pieces of your data. If you have incomplete or inaccurate information, then you're risking to have some sort of data inconsistency that basically means some data quality issues that basically means that some of your records might be missing or simply completely outdated. And one other consequence will be low performance. So if the data is not really properly structured or organized, getting any sort of insights from it, it will probably be slowed down because of it. And on top of that, you have operational challenges. So managing this data over time will become a bit of a struggle.
So the underlying message there is keep your data structured, I guess.
Yes, or make sure that you have all you need properly stored in a place that later on you can reuse.
Makes sense. And I guess then that brings me on to, like, in terms of the type of data storage, I guess the most obvious question in that regard is like, what is the difference between a data warehouse and a data lake? Like, why would I use one or not the other, or a combination of the two? Or explain, please.
So basically, in data warehouses, we have the data a bit more structured. So before you write the data into the data warehouse, you have a schema predefined. And usually this data goes through an ETL process. That basically means that the data is extracted, transformed, and then loaded into the data warehouse. And in this case, the data is already cleaned and analytics ready and can actually be used across the organization as a single source of truth. And even business users can use this data to build insights, let's say.
So sorry to interject. So in that respect, you're kind of querying the data warehouse directly with the analytics, and you don't necessarily need anything in between then. Is that
Yes, precisely. So for instance, that's what we do in Good Data, where we basically live query all your data because they're already analytics ready.
Makes sense.
And then we have in data lakes a bit more flexibility when it comes to the type of data that you have structured. So data lakes allow you to store any type of data in raw, unstructured, and structured format. And this is basically the main reason why they're considered highly flexible and scalable. And in this case, the data could actually go through a different type of process, which is called ELT. That basically means that the data is extracted from a source, loaded into the data lake, and once it's time to be read, it's going to be transformed. And typically, this is handled by data engineers or data scientists. So if we can summarize all of this in like a couple of points, I would say that the main differences are the data structure. So in data lakes, you have raw, unstructured, and structured form, whereas in the data warehouse, you would have structured data in which the schema is defined before the data is written there. Then it comes to also the schema. So the schema for the data lakes is on read, which means that you can define the schema once you're reading the data. And in the data warehouse, this schema is on write. So that means that once you're writing the data, the schema has to be already defined. Then the type of users that you have behind the scenes, you have in data lakes, data scientists and data engineers working with the raw data. And in data warehouses, you can actually have business analysts using this data to build insights. And then the costs. Generally speaking, data lakes can be cheaper than data warehouses.
Okay. And then, so, I mean, so one of the main reasons in terms of like whether I'd use a data warehouse versus a data lake, I'm assuming in terms of cost, a data lake is a lot cheaper because of the fact that you have it in this unstructured form, and it can be raw data, unstructured data, rather than with a warehouse where it's kind of structured, and obviously you pay for that structure to the data, right?
So with the data warehouse, you have costs that are kind of associated to the computational behind the analytics queries. So this is mainly one of the reasons why it can be a bit more costly than the data lakes.
And actually, we've got a relevant question here. If you store data in raw and format form, that sounds like a lot of storage is needed. How is this cost effective?
So if we're talking about data lakes, again, they're usually cheaper and easy to set up and scale because you're basically saying very simple words, dumping your data there, and later you're able to actually go back and restructure it properly. So in the end, it might actually be cost efficient depending really on the use case.
Sure. So yeah, and then in terms of use cases, for instance, it could be, and correct me if I'm wrong, but I could kind of use a data lake, for instance, to store a lot of unstructured or raw data, and then maybe use a data warehouse purely for the structured data that I'm using right now. So for instance, I'm running analytics on a day-to-day basis on this structured data within the warehouse, but then I have a big load of unstructured or raw data sitting in a data lake that I know that I want to keep, but maybe I don't need it, right now, but I want to keep it for the future and maybe do something with it at a later date.
Exactly. So basically, these two options, they are not mutually exclusive, and you can even use a combination of both. And again, it comes down to your use case. So you can have in your data lake, your data lakes, your unstructured raw data. And then on the side, you can have your data warehouse where you're sending all your analytics ready data that you can directly query.
And then actually another question we have related to that. If you query kind of your data lake, you need to transform the data anyway. So the compute will be paid for eventually, right? Or in some cases, the cost could be higher since you need to scan or load more unstructured data from storage. Is that correct? Or what would your thoughts be on that?
So basically, one thing to keep in mind is, as this person probably said, once you have the data in the data lakes, you have to somehow prepare it. So you would still have to transform it to make it readable, or you can actually perform some sort of advanced analysis on top of raw data. It really, again, depends on how you plan to use this data.
Okay, yeah. No, that makes sense. In which case, I guess the next obvious question from me is kind of what are the kind of the main use cases for each type for data lakes and data warehouses? I guess that would go some way to kind of answering that question as well, right?
So for data lakes, we have, for instance, real-time analytics. So in case you need to perform analysis on top of streaming data in real time, you should be able to use it. And some of the industries that might be kind of commonly using it is finance and IoT. Then you have machine learning. So being able to use machine learning models to generate insights, to perform forecasting, predictive analytics. Then we also have data exploration. So without precisely structuring your data, still being able to identify patterns, trends, and insights. And then we have also BI and analytics on large amounts of data. And then when you go to data warehouse, you have the possibility of doing data mining. So you have the structured historical data that you can use to perform this analysis to identify patterns. Then you can also use to perform market research and trend analysis, and also BI and reporting.
Okay, cool. So yeah, so there's kind of this like obvious use cases for each. Again, I guess depending on how available you want the data to be and whether it needs to be kind of structured or unstructured.
Exactly.
If I'm an organization like evaluating data storage options, kind of what are the fundamental aspects I should account for? Like what should I bear in mind when I'm kind of looking to store my data and looking at best practices, that kind of thing? Is there any kind of pointers that you'd give?
So basically, the storage should act as an enabler to support the organization reaching its goals. So when you're choosing your data storage, you should take into consideration what are the main concerns, what are the main points that the organization wants to tackle. So for instance, the scalability. Is this data storage able to accommodate my growing data over time? Performance. What are the performance requirements that I would expect from my data storage? Collaboration. Security. Would it be able to implement security measures and be compliant with all the industry standards that my organization expects? So these are just a couple of the points that should be considered.
Sure. And in terms of scalability, for instance, I guess then it depends also, like in terms of like what are you doing with that data? For instance, like a big part of kind of good data and our kind of data analytics platform is like the scalability is one of the factors that we mention is kind of a differentiator for some of our prospects to come to us to speak to us is the scalability. So I guess that then is obviously like from the raw data right to the insight. Scalability, I guess, is key in ensuring kind of if you think that the volume of data will grow a lot or the number of users, etc.
Exactly. Yes.
And then I guess the knock-on effect of that is performance, right? I mean, it needs to perform with growing scale of the amount of data and users. Cool. Trends. What are the kind of current trends you see at the moment in terms of data storage? I guess most specifically within kind of the data analytics and BI sort of space. What seems to be kind of the current trend in terms of how people are storing data, that kind of thing, their requirements?
So what we see often with our clients and prospects, it's basically the search for centralizing their data, having the entire data consolidated in one place, and have actually different schemas for different use cases. And this it's mainly for optimization and cost control. So having this data centralized makes it more efficient because you are not managing data across different systems, reduce redundancy, makes the integration with other systems smoother since you have less complexity, and the cost of the data integration also decreases because, again, you have everything in one place. And then on top of that, there's also some sort of cost savings since you don't have larger teams to manage different systems.
Okay, so the goal with that basically is really just trying to use one specific storage. Is there, like, this might be a silly question, but in terms of like, why would you have it in multiple different storage, like data storages, rather than in a single one in the first place?
So what would often happens is that, for instance, you have clients using different storages and they're just spread across, or you have some data stored in Azure because they are part of some Microsoft services that you have. And then, it just really depends. And beforehand, we wouldn't have this big concern on having the whole data centralized. So it wouldn't be actually a problem to have it spread across different storages.
Okay, so that makes sense. And then with like the rise, etc., of Snowflake, for instance, that is one of the reasons is due to the fact that people just want that one data warehousing solution, I guess, so that they have everything stored in one place, right?
Yes. And then just to kind of add to that, there's also a bigger search for cloud-based solutions, and this has been going on for quite a long time. It's not really a brand new trend, but basically cloud-based solutions, because it can increase the agility, it's more cost efficient, and makes it easier to access some advanced analytics capabilities. So once the organization moves to a cloud-based solution, they can easily scale not only the storage but also processing capabilities to meet their needs at that moment. They have more seamless integration with cloud solutions. So for instance, if you would like to connect to good data, that would go smoother with a cloud-based storage. And then you can also easily share and collaborate with internal and also external teams.
Okay, cool. Yeah, I mean, and in terms of the, like you're speaking about kind of the reasons for cloud solutions, and we were talking earlier also about kind of the costs of data warehousing versus data lakes. I guess some of the costs are associated around querying the data, right? And I guess what's one of the ways you could reduce those costs? I assume like caching, for instance, is one way of doing that.
Yes, so basically, for instance, in Good Data, we have our Flex query in place that it's basically a caching layer in between your storage and Good Data, but it's kind of a advanced storage because it can actually predict usage, and it caches your data in a smarter way. And because of that, it can actually help you reducing some of your querying costs in the storage.
So I guess it defines what you can take from the cache and what doesn't need to be queried directly each time with the data warehouse. And then the knock-on effect, of course, is less queries and less money spent. Okay, cool. We don't have any other questions right now from the audience. So I think that wraps it up. Is there any other final thoughts you have on data storage at all?
That should be it for me.
Okay, then. Well, thanks everyone for joining. Thank you for your questions. That wraps up today's episode. Thanks, Maria, for answering all my questions. I hope kind of everyone learned something about data storage today and some best practices, some of the different trends, as well as a little bit about good data. If you'd like to kind of learn more about data storage and preparation, as well as other analytics kind of related topics, head to our website, gooddata.com. You can head to the blog section, the resources for further kind of reading and learning materials. Again, thanks everyone. We hope to see you next time, and we'll post a bit of further reading material within the comment section after the show. Thank you.
Thank you.